Okay, here we are. This is the formula of a hydrate PreLab. What I need you to do is pause the video for a second, or a few seconds, and I need you to copy this data table, and you should probably title it Formula of a Hydrate PreLab. You don't necessarily need to write the goal, but definitely copy the data table. So pause the video and do that, and then we will get into the steps for these calculations. Okay, so the goal for this lab, this is a PreLab, okay, is to find a formula for this hydrate of magnesium sulfate, okay? So what we have, this data is a student weighs a crucible, then they put some hydrate in the crucible. So hydrate in the crucible weighs more than the crucible. That should make sense because you've just added hydrate to it. So now it's got a compound in there and it's heavier. Then you heat it. You heat the hydrate. Now remember, a hydrate has water molecules absorbed into the crystalline structure. And when you heat it, those water molecules escape the crystalline structure, okay? So the water goes away. And what's left in the crucible after you've heated it is an anhydrous salt. Anhydrous means without water. And salt is not just table salt. Salt is almost any ionic compound. So lots and lots of ionic compounds fall into the category of salt. Not all of them, but a lot of them, okay? So anhydrous salt in the crucible weighs 13.14 grams. That's less than the hydrate because what just left? What did we do? We heated out the water, okay? So hopefully that's something that you're following along. You heat it strongly, the water goes away, okay? Well, this hydrate for this PreLab is a hydrate of magnesium sulfate. We need to know what the formula of magnesium sulfate is in order to do our calculations. And we're going to put that together right now. So magnesium, if you guys remember or look on the periodic table, is Mg, okay? And that has a 2+ charge, 2+. It's in group 2, so it loses 2 electrons to become stable, okay? Sulfate is one of our flashcards, our polyatomic ions. It's SO4. Well, sulfate has a 2- charge, 2+, 2-, they balance each other. So this is the formula of magnesium sulfate, okay? And we're gonna need that because that is the salt part of this hydrate, okay? So the salt that's left in the crucible after heating, that anhydrous salt, that is magnesium sulfate, okay? What we are trying to do is figure out what goes in this blank right here, okay? Every mole of magnesium sulfate absorbs X number of moles of water into its structure, and we're trying to figure out what X is, okay? And that's the process I'm going to walk you through in this PreLab. So I'm going to pull the next board here. Keep your data table handy. Here's our first 3 steps. You don't necessarily need to write out what I've written here, but you do need to show your work. So if I show work, you need to show work, okay? So number 1 says complete the data table. Well, over here, we need to find the mass of the hydrate, the mass of the anhydrous salt, and the mass of the water lost, okay? Well, the hydrate, we have in the data table the mass of the hydrate in the crucible, and we have the mass of the crucible. So this is like the mass of a box of shoes and the mass of a box. We subtract and we can figure out the mass of the shoes, okay? So the hydrate in the crucible was 13.49 grams, and the crucible by itself was 12.77 grams. We do that subtraction and we end up with a number. Hey. Yeah, that's okay. Where'd you get those?
Took them out, man, and they're all
crisp and fresh?
Yeah. You want me to just hand through and put them down somewhere?
It doesn't matter.
All that.
You just found those in your room?
Yeah, in some drawer, and I was like,
sweet.
They were made for whoever, they're thick, plasticky.
I made them.
You did?
Uh-huh,
Okay,
yeah.
they're nice.
I made them I made that whole periodic table in Excel,
Oh my God.
and then
Yeah, these have never been
I
used.
got them printed from Modern Printing. Yeah, I made those.
Well,
I paid thousands of dollars for them.
did you really?
Yeah, but we got a lot of them. We got like 2,000 of them. So sweet. Thanks.
Sorry to interrupt you.
You're good.
Thank you. Yeah, bye.
See ya. Okay, so we end up getting 0.72 grams for our hydrate. Okay, remember that's before we've heated it. That is the magnesium sulfate with the water absorbed. Okay, so go ahead and fill in 0.72 grams into your table, 0.72 grams. Okay, next, the anhydrous salt. Well, again, in the data table, we have the mass of the anhydrous salt in the crucible, and we have the mass of the crucible. So we just do a little subtraction there, okay? So 13.14 grams, subtract the crucible, okay? I mean, look at the words. If you look at the words, anhydrous salt in crucible. If I want the anhydrous salt, I need to get rid of the crucible. So I need to get rid of the mass of the crucible. Okay, use the words. It's logic. Okay. All right. So we do that subtraction, and we end up with 0.37 grams of the anhydrous salt. Now remember, that's magnesium sulfate. So you could put that there just to remind yourself later, and then go back to your data table and fill in 0.37 grams for that magnesium sulfate, that anhydrous salt. Okay. All right. Now here's a little bit more of a puzzle. The water lost. How much did that weigh? Well, remember, we heated it to get rid of the water. So there's two different ways we could do this. One, hydrate means with the water, anhydrous means without the water. See, we lost mass. The mass that we lost is the water. Similarly, when we had the hydrate in the crucible, we heated it, it got lighter, anhydrous salt in the crucible. The reason it got lighter is because the water went away. So we could subtract these two numbers. Either way, you're going to get the same answer. I'm going to use the secondary, or the first way I said, okay, I'm going to use the hydrate mass was 0.72 grams minus the salt, 0.37 grams. And I'm going to get the mass of water as 0.35 grams of water. 0.35 grams of water. And I'm going to go back over here and fill that in. Okay. Don't forget your units. All right. Second step. Here we go. Determine the moles of salt and water lost by this sample. Okay. So salt and water in this sample. In the sample of hydrate. Remember, this 1.72 grams, that's the hydrate. That's the magnesium and the magnesium sulfate and the water together. We want to separate them now. We're doing an empirical formula calculation. We want a mole ratio of salt to water. Okay, so I need to figure out moles of salt. Well, I'm going to start with my 0.37 grams MgSO4. We know how to do a grams to moles calculation. We use the molar mass. Where does 1 mole go? Well, we don't want to cancel moles. We want to cancel grams. So 1 mole of MgSO4 goes on the top. We need to add up the molar mass of magnesium sulfate in order to figure out what number goes on the bottom. So we look at our periodic table. We see magnesium is 24.3. Sulfur is 32.1. And 4 oxygens is 4 times 16, 64.0. So altogether, this salt, magnesium sulfate, weighs 120.4 grams for every mole. Okay, so that number goes down here, 120.4 grams of MgSO4 for every 1 mole of MgSO4. Hi. Right now?
Yeah.
I need probably about 15 minutes to finish making this video.
Yes.
Will that work?
Yes.
Okay, thank you. So we punch that into the calculator and we end up with moles of magnesium sulfate. This only has 2 sig figs. So my answer is going to be 0.0031 moles of MgSO4. Okay, 0.0031. And I wrote it small like that because I'm going to run out of space if I keep writing as big as I am. So that's the moles of the salt done. Now we need to do the moles of water. Well, we need to start with the mass of water, 0.35 grams of water, okay? So 0.35 grams of water were lost in this heating process. Again, grams to moles conversion is molar mass. Where does 1 mole go? On the top, 1 mole H2O. On the bottom, we're going to end up with the molar mass of water. Well, each hydrogen weighs 1, oxygen weighs 16. So when you put those two together, or those 3 atoms together, you end up with 18. So 18.0 grams is the molar mass of water. Okay, this one also gets 2 sig figs because of my 0.35 here. So we're going to do that division, and we end up with 0.019 moles of H2O. 0.019 moles. Now, be careful on the next piece. It says divide by the smallest number of moles. Don't just look at 19 and 31. You need to look at how many zeros are in front, right? So 0.0031 is smaller than 0.019. It's not about the non-zeros, it's about the zeros in this case, okay? So more zeros after the decimal means smaller number. We're going to divide both of these by the smallest number of moles, just like we do in an empirical formula. So we have 0.0031 and we have 0.019. We're dividing both of them by 0.0031. Remember, you should always get 1 for one of your answers because you're dividing it by itself. So this is 1 magnesium sulfate. And then you should get a number that's bigger than 1 for the other one. Otherwise, you didn't divide by the smallest number. When we do this, we get 6.12 waters. Okay? Now, in an empirical formula calculation, I told you it will either turn out to be a whole number, or it will end up being something that's a recognizable fraction that we can work with and multiply and yada yada. Okay? Now, in this lab, we are not expecting you to get a whole number. If you do, it's good, but if you don't, that's okay. But remember, we are trying to find a whole number that goes in this blank, okay? It is going to be a mole ratio between the salt and the water, and it should be a whole number if we were perfect, but we're humans. Our data is not going to be perfect, so that means that we are going to have to round whatever answer we get to a whole number. So in this case, 6.12 is going to round to 6 waters. We're going to round it to a whole number. Don't try to find a multiplier for the lab. You do that in your problems, but not in the lab because the lab is imperfect, okay? So the next steps. Number 4, what is the formula for this hydrate? Well, it's what I had on the other board. MgSO4 dot blank H2O. Remember, we're filling that blank in with a whole number. We don't necessarily have to draw the blank. Our number is going to be 6 because my moles of water over here, 6.12, rounds down to 6. So 6 H2O, that's the formula for this hydrate, okay? All right, number 5, last piece that you will have to do in your lab as well is what is the percent water in this sample? Well, we're going to use our data for that. Remember, percent composition is always based on mass. Well, I had 0.35 grams of water in this sample. I'm trying to find percent water, so I need that number, 0.35 grams of water over the total mass of the hydrate. Okay, it's not over the mass of the salt because the salt doesn't have water, but the hydrate did. Okay, so this is one piece of the hydrate, this is the other piece of the hydrate. If I want to find the percent composition, I need to do a piece out of the whole times 100. And the whole in this case is 0.72 grams of hydrate. I'm just going to write hydrate. Oh, times 100. Okay, 0.35 grams of water over 0.72 grams of hydrate times 100. We only want 2 sig figs because of our data, so we have to round our answer to 49% water. So 49% of the mass of this substance is water, which is pretty cool. That is the end of the pre-lab calculations, but there's one more step that we need you to do in order to get ready for your lab. So I need you to pause your video. You could start a fresh piece of paper if you want to, but pause your video, copy down this data table so you are ready to gather your data in the lab when we get going in your next class period. So pause the video right now, copy that down, and then push play again because we're going to need to do a couple more things. Okay, we're going to do 2 little things to prep for the lab so that you're ready to do your calculations tomorrow after you get your data. The first thing is for our lab, and again, you don't need to necessarily copy the whole question here, but maybe put lab prep, and then you're going to put what I write down here in that section. So for our lab, we will be determining the formula of a hydrate of copper 2 sulfate. So we're not using magnesium sulfate like the pre-lab, we're using copper 2 sulfate. So first, what is the formula of copper 2 sulfate? Well, remember, this, with that Roman numeral, tells me the charge of the copper. Cu2 plus is copper 2, right? Sulfate is still SO4 2 minus. So those two go together, they balance. So the formula for copper 2 sulfate is CuSO4. Remember, formulas, when you put them together, they don't have charges. We just use the charges to balance them. And then what is the molar mass of copper 2 sulfate? This is important. This is really important because in the process that we just did, you guys had to find the number of moles of salt and water. And the salt for you in the pre-lab was MgSO4. So you had to find the molar mass of MgSO4 and use that to convert to moles. Don't use this number anywhere in your formula of a hydrate lab tomorrow. Don't do it, okay? This is the molar mass of magnesium sulfate. Your salt is copper 2 sulfate. So we need to take a little minute and figure out the molar mass of copper 2 sulfate, and that's what you will use in your calculation for moles of salt tomorrow, okay? So copper 2 sulfate, add up copper, sulfur, 4 oxygens, and that piece I'm not going to give you. You can do that on your own. Add those things up, get your molar mass, and when you submit this pre-lab, you need to make sure that you show all the calculations from the pre-lab, the data table that's ready for data tomorrow, and this section so that we see that you did your whole pre-lab. Thanks for tuning in, and we will see you in class.